What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we start a new unit focused on sequences and series. Today we are going to dive into the first section, which is basic sequences and series, an introduction, if you will. So we're going to focus on right now finding the terms of a sequence. So first we probably need to understand what a sequence is. A sequence is a list of numbers that come in a specific order. So for example, this may be a familiar list that you might have. This would be, let's say we have 1, 3, 5, 7, 9. You could probably figure out how to come up with these numbers or how this list was created, but this would be a sequence. It's a list of these numbers in this order. Now, this is what we would call a finite sequence because it ends based on what we have here. Now, we could continue and write this notation. You see these 3 dots, meaning that the sequence would continue. This would become an infinite sequence, where we would, in effect, be talking about all positive odd numbers, as you see here. Now, another way that we could write this is without identifying exactly what the terms are individually. So we could write this as maybe a sub 1 to a sub 2, a sub 3, and then so on and so forth. And this would be a sequence here where a is the term. So a sub 1 would mean first term, a sub 2 would mean second term, a sub 3 would mean third term. Currently, this sequence would be infinite, as it shows it's going to go on forever. But now let's go ahead and let's write this to the a sub nth term. Now this would be a finite sequence because there is an ending. Whatever the nth term here is, and we don't know exactly what n's value is, but that would be the conclusion of the sequence. So all of the terms from the first to the nth term would be part of the sequence. So finding the terms of a sequence is a skill that requires just some basic algebra 1, depending on the format. So in problem number 1, we have the format given for a general term. It says, for the sequence below, find a1, a sub 2, and a sub 6. So what this is giving us is an equation to find any term of the sequence. So a sub n just means the nth term in the sequence. So if I want to find a sub 1, this would be the first term in the sequence. What I could do is I could take 1 and substitute it in for n. So 1 plus 1 over 1 squared. And we know 1 plus 1 is 2. 1 squared is 1. So the first term of the sequence would be 2. Now I could find the second term by doing the same thing. 2 plus 1 over 2 squared. So substituting 2 in for n. 2 plus 1 is 3. 2 squared is 4. So the second term of the sequence would be 3/4. We could do the same thing on, and let's find the sixth term. So I would substitute in 6 for n. So 6 plus 1 is 7. 6 squared would be 36. So we can see these would just be some terms in this sequence. 2 would be the first term. 3 over 4 would be the second term. 7 over 36 would be the sixth term. And we could go on and on to find an infinite number of terms in this sequence, assuming that it is an infinite sequence. So this formula was given just to find a general term. In part B, or problem 2 here, see if you can pause the video and find each of the first 4 terms of the sequence. Hopefully you've gotten a chance to take a look at those. In our first case, we're going to look at a sub 1, which is the first term of the sequence. So this would be -1 to the first power times 2 to the first power. So -1 to the first power is 1, or sorry, -1. 2 to the first power would just be 2, and so we would have -2. We can also find this in the calculator here if we go -1 to the first times 2 to the first, and that's -2. Now if I want to find the second term in the sequence, I can do -1 to the second power, 2 to the second power. So -1 to the second power would be +1, 2 to the second power would be 4, and so I'd have a +4. Again, we can do this in the calculator. If I do -1, sorry, a little mistake there, -1 to the second power times 2 to the second power, I get the answer 4. So repeating this process for the third term, we have -1 to the third, 2 to the third. So -1 to the third is -1 times 2 to the third would be 8, and so this would be -8. Finally, 8 to the fourth term of the sequence, would be -1 to the fourth, 2 to the fourth. And we would have -1 to the fourth as +1, 2 to the fourth would be 16. So you can see that the terms of this sequence go up by 2 and also change signs. So each term is essentially -2 times the previous term. Now, this is just a way to find them using the general formula. You can also use your calculator if you know the general formula to quickly find some terms. So if I did -1 to the x power and 2 to the x power, so I'm typing in this general form and replacing the n with x, I can go to my table and find, we don't want to start at 0, we want to start at 1, but I can find each term. So the first term is -2. The second term is 4, the third term is -8, and the fourth term is 16. So finding terms of a sequence, which again is a list of numbers in a specific order, can be done through some simple substitution. And this is a great place to stop. Thank you guys for tuning in. And as always, I'll see you soon.